In 2011, Netflix made a decision that confused a lot of people at the time. They were one of the fastest-growing internet companies in the world, handling millions of streaming sessions every night, and they announced they were moving entirely off their own servers and onto Amazon's cloud. The reason they gave was not that their infrastructure had broken down. The reason was that making their servers bigger had stopped being a viable strategy. They had hit a wall that every growing service eventually hits, and they decided the only way forward was to change the shape of the solution entirely. The wall they hit has a name. Understanding it, what it is, why it forms, and what replaces it, is one of the most important ideas in cloud computing. When a server starts struggling under load, the first instinct makes complete sense. Make it more powerful. Add more memory so it can hold more data in fast access storage. Add more processor cores so it can handle more tasks simultaneously. Upgrade the network capacity so requests can move in and out faster. This approach has a name: vertical scaling, or scaling up, and for a long time it was the only option that existed. And it works. Genuinely, it works well. Double the memory, and your server can handle roughly twice as many concurrent users before it starts to fall behind. Add more cores, and more requests get processed in parallel. The relationship between investment and capacity is reasonably predictable, and for a service in its early stages of growth, vertical scaling is often the right call. The problem is the curve. Imagine you run a kitchen. One chef, one stove, one workspace. As orders come in faster, you upgrade the equipment. A better oven, sharper knives, a larger prep surface. The chef gets more done per hour. You upgrade again. A professional range, a walk-in refrigerator, a workspace 3 times the original size. Output improves again. This is the obvious thing to try, and it works. But at some point, you have bought the best equipment that exists. There is no faster oven on the market. The workspace is as large as the building allows, and you still have one chef. That chef is extraordinarily well equipped, but they have 2 hands and 1 body, and are working at the physical limit of what a single person can do. You cannot make them faster by spending more money. The ceiling is not financial anymore, it is physical. Servers hit the same ceiling. There is a most powerful machine you can buy. At the top end of the market, adding more memory becomes exponentially more expensive for diminishing returns. Some architectural limits cannot be crossed at all. A single processor can only execute so many instructions per second, regardless of what you pay for it. And the kitchen analogy holds in one more important way. If your one chef gets sick, the kitchen closes. If your one server fails, your service goes down. Vertical scaling, taken to its limit, produces a system that is simultaneously maximally expensive and maximally fragile. You have put everything on a single point, and single points fail. This is the wall Netflix hit. Not because they were doing something wrong, because they had followed vertical scaling as far as it could take them and found that the top of that path was not high enough. The answer is not a more powerful machine. The answer is more machines. Return to the kitchen. Instead of continuing to upgrade a single chef's equipment, you hire a second chef, then a third. Each one has a reasonable setup. Not extraordinary equipment, but solid. What changes is that 3 chefs are now working in parallel, taking different orders, preparing different dishes at the same time. Output triples, roughly. Add a 4th, output increases again. There is no physical ceiling on how many chefs you can have, as long as you have the space. And in a cloud environment, space is effectively unlimited. This is horizontal scaling, or scaling out. Instead of making one server more powerful, you run more servers. Each one handles a portion of the incoming traffic. When demand rises, you add more servers to the pool. When demand falls, you remove them. The ceiling moves with you, because the ceiling is simply the number of servers currently running, and that number can change. Cloud computing was built around this approach, not as a preference, but as an architectural philosophy. The entire model of spinning up new instances on demand, distributing traffic across many machines, releasing capacity back when it is no longer needed, all of it assumes that your application can run across many smaller machines rather than one large one. The cloud data center is at its core a very large number of relatively ordinary computers coordinated to behave as one very large resource, horizontal all the way down. There is something worth pausing on here, because horizontal scaling is not free. The chef analogy still holds a little longer. When you have 3 chefs instead of 1, they need to coordinate. Who is handling which order? If 2 of them reach for the same ingredient at the same moment, there is a conflict. If one chef is consistently faster than the others, the kitchen develops a new kind of bottleneck. Managing multiple chefs requires systems that a single chef never needs: communication, shared understanding, rules for who handles what when things overlap. Servers face exactly the same challenge. When 10 servers are handling the same application, they need to agree on things. If a user logs in and their first request goes to server 3, but their next request goes to server 7 needs to know who that user is. If 2 servers attempt to write to the same piece of data at the same moment, you need a rule for which one wins. Horizontal scaling distributes the work, but it also distributes the complexity. Applications have to be designed to run across many machines, and that design is harder than designing for one. This is why the shift from vertical to horizontal scaling was not simply an infrastructure decision. It was an architectural one. It changed how software is written, how databases are structured, how state is managed across many running instances. Netflix did not move to the cloud and carry on as before. They spent years rewriting the internals of their systems specifically to make them capable of running horizontally, broken into independent pieces that could each scale separately, rather than one large application that had to scale as a whole. What you understand now is the fundamental fork in the road that every growing service eventually reaches. You can make one machine more powerful, and that works, until it stops working, and under enough demand it always eventually stops working. Or you can spread the load across many machines, accepting the coordination complexity that comes with that choice in exchange for a ceiling that can move as high as you need it to go. Cloud computing made horizontal scaling not just possible, but practical. The trade-off is real and worth knowing. Distributed systems are harder to build and harder to reason about than single machines, but the alternative is a ceiling. And ceilings, under enough load, always win.